Welcome to another part of the ISM course in Statistics 1, this time with a unit on basic statistical terms. Let's start with the different data types. Here we have three main forms we can differentiate. The first and the most common one is if we only have cross-sectional data, meaning we have different observations but only for one point in time. The most common example would be surveys. I have one point in time and the different people who I give my questionnaire to or which I observe, those are the different cross-sections. Time series, that's the exact opposite. Here I have only one cross-section but many different points in time. So for example, I observe one person and take different snapshots during different time periods. So if I want to see how someone develops over time, that would be a typical time series. So cross sections, one point in time, different observations. Time series, one observation, different points in time. Panel data finally combines cross-sectional and time series characteristics, meaning we have different cross-sections, a number of cross-sections, and different points in time. So, for example, I observe a set of people. I have, for example, 10, 20 people I observe over the course of many years. And each month I take a survey with them, or I analyze specific behavior patterns. So this generates panel data. So with this in mind, we can directly turn to the second part. In the second part, here there's the difference between quantitative and qualitative data. So we have the two different aspects, qualitative, quantitative. Qualitative, that's for example artworks. I can describe an artwork, but it will be relatively problematic to do this with simple numbers. So what we usually do is we describe like feelings, how the colors are composed, how they interact with each other. That's qualitative. Something which can only very problematically be transformed into numerical statistical information. On the other hand, if we have like monetary values, if we have economic values, GDP, unemployment rate, that's typical quantitative data. Data which can easily be analyzed statistically. That's also the main point I want to get across here. When we're working with broad field of statistics with data, what we usually use is quantitative data. There are some small points where qualitative data can enter our overall, regression analysis, for example, or other aspects. But in general, we only work with quantitative data. Data where we can count, where we have specific values for our variables. And the next part would be something called descriptiveness. Again, here we can differentiate between descriptive variables and non-descriptive. Descriptive means I can have more than one characteristic. So if I consider cars, or rather my own cars or someone's cars, he can have cars from different manufacturers, different brands of cars. So here, like the owned cars, a variable called owned cars, can have more than one value because someone can have more than one car. On the other hand, if our variable is about popes, at each point in time, at least from a legative point of view, there's only one real pope. So this is a variable where there's always only one possibility. So therefore, we call this non-descriptive. So descriptive means I can have more than one characteristic. Non-descriptive means there's always only 1, which is possible. So same thing could go with first names. First names, someone can have more than one first name, so this would be descriptive. Someone could have more than one mobile number, so this would also be descriptive. So we see a lot of typical variables which we might know is descriptive. On the other hand, something like birthplace. Someone can only be born in one specific place, so this would be typically non-descriptive. So far on descriptiveness. And then the next part, that would be continuity. Here we can differentiate between continuous and discrete variables. Continuous means we do not have specific steps. If I take two specific values, the one in between those two is also a valid value for my variable. So if I have like two different points in time, I can take any value from between those 2 points and would still be a decent value. So I have like 2 o'clock, 3 o'clock, then any value in between would be a valid, well, time. If I have like a period of time, like 2 hours, 3 hours, then anything between 2 and 3 hours would also be valid. On the other hand, with discrete variables, I have something like books, or more or less pages in books. I have like books with 10 pages, 100 pages, 200, 3000 pages. But if I have a book with 300 pages, the next largest size would be 301. In at least normal and standard books, I do not have like half pages, quarter pages, or something like this. So I only have like 1, 2. Nothing in between. Now we can say, well, if I have something like income, in the end I'm paid in euros or in cents if we go into more detail, and there's a difference like from 2000 euros 0 cents to 2000 euros 1 cent. So this would also be discrete. Yeah, this is theoretically speaking a discrete variable, but we can treat it as if it were continuous, because theoretically we could make it smaller and smaller and smaller. We could say he earns like half a cent. It's, for example, gas prices, depending on the country, is always like 0.9 cents. Something before this, but 0.9 cents. So this means we can theoretically go deeper. However, just the money which we usually use, the prices which we usually see, they are giving and they are motivating some kind of discrete nature. However, we can use this, and whenever we have variables like this, which on the one hand seem to be discrete but can be handled as if they were continuous, we also call them quasi-continuous. So more or less continuous, can be used as continuous even though they might not be. So this much on continuity. We then already come out to our last part, and that's the difference between the different scale levels. We see here we differentiate between 4 different scale levels: nominally scaled data, ordinal, interval, and ratio scale data. Nominal, that's again our cars. That's like different car brands. I can go and say, well, this is an Audi, this is a BMW, Mercedes, this is a Fiat or something, but I cannot say that like a Ford is more car than a Fiat. So I can differentiate, I can count, for example, how much Fords are parking in one street, but I cannot arrange them in an ascending or descending fashion. That's nominal data. We can count it, but we cannot arrange this. If you can arrange this, this is ordinal data. This could be like hierarchies in church, hierarchies in the military, where you can say he's ranked higher in his organization than someone else. But not necessarily is the difference between a cardinal and a pope comparable to the distance between a bishop and an archbishop. So the distances cannot, or not necessarily, can be really compared or quantified. That's the downside to ordinal data. Yeah, we can order it, so we have an ascending or descending order, but we cannot be sure about the distances. As soon as we can say something about distances, we have at least interval scale data. That could be something like this here. This is the Elbphilharmonie, this stands for music. In particular in music I can say this note is higher, is this much higher than some other note. However, with music, with notes, tone heights, I have the same problem as when I talk about temperature, and in particular temperature in degrees Fahrenheit or degrees Celsius. If I have 0 degrees Celsius and I cannot say something like, tomorrow it will be twice as cold. What's like twice of 0? That's the problem. Intervally scaled data, I know something about the distances, but I do not know in reference to which value something occurs. So I cannot say something like twice as much, half of. This doesn't make sense. Doesn't work with temperatures, or not necessarily with all of them. With degree Kelvin it would work. Also it doesn't work with birth years. We cannot say someone is born in the year 2000 and have someone who's twice as old as him, so he needs to be born in the year 1000. Also doesn't make sense. That's the reason because we do not have an absolute null. So we do not have a 0 point of reference where all of this starts. And this we have, for example, with income. We have an income of 0, so we have always some point of reference, some absolute point of reference. Thereby we can say this guy earns twice as much as someone else. Now earlier I said, well, temperature in degrees Kelvin, this would also work. Why? Well, there's 0 degrees Kelvin, and putting aside the newest insights from physics, basically you can say there's no possibility that we get below 0 Kelvin. So 0 Kelvin is the absolute minimum, so we can see everything in relation to the 0 Kelvin. Thereby we have an absolute reference point, an absolute null, and we can also say with everything this is twice as warm, twice as cold as someone else, as something else. So if we compare, again, summarize, nominal data can only be counted, ordinal data can be counted and arranged in an ascending or descending fashion, intervally scaled data can be counted, arranged, and we can say something about the distances. Mathematically speaking, this means we can add and subtract. And with ratio data, we also have an absolute 0. So we can say twice as much, half as much. So this means mathematically speaking, we can multiply and divide. So much for this. In many cases in statistics, you will, however, see a different term. This is something called metric data. Well, metric data is nothing really fancy. Metric data is just like a term which summarizes interval and ratio scale data. So as soon as it's interval, it's also metric. Thereby, we also covered this part. Well, and this then already concludes this short introductory lesson on different basic terms in statistics. I hope you learned something from this. And if you want to see different other courses of this type, feel free to visit the rest of this playlist or the rest of the statistics course. Until then, see you and goodbye.